All right. On this page, I don't remember, we're sketching here, okay? These are not going to be exact. They're just going to be sketches. But the point of this exercise, exercise 2, is that we need to see how the leading coefficient affects our parabolas. So, if we take a look at y equals 3x, so I'm going to look here, y equals 3x squared plus 6x minus 4. Yes, I want you to draw your graph. Okay, notice that we've got a standard window, so it's x is going from negative 10 to positive 10. The y's are running from negative 10 to positive 10. Okay, and we're showing that this is y equals positive 3x squared. Notice how the c term is negative 4. Watch what this looks like when it gets graphed. Let's see if I can match what the graphing calculator looks like. Okay, notice where it's crossing the y-axis. Notice it's a little shifted off to the left side. But most importantly, notice how it opens up. Okay, so positive leading term, the positive 3 tells us that it's going to open up. Okay, so because a, okay, remember we're thinking about y equals ax squared plus bx plus c, okay, and we're talking about how a affects the opening direction of the parabola. That's what I'm trying to get you to see. All right, let's check out the next one. So here's y equals negative x squared plus 6x plus 1. Okay, this one is going to be wider. It's going to open down. And that's all because the negative x, the a, so let's say a equals negative 1, and that means that it's going to open down, so concave down. All right, let's check out the third one. Again, we have y equals negative 2x squared. Again, we have a equaling negative 2, and this is going to tell us that our parabola is going to open down. So this one is very shifted to the left. Okay, this one's going to cross right about. Let's see if I can try that again. I'm not going to draw the whole thing that way. We can still see what I wrote. The a equaling negative 2 causes it to open down. Actually, let's do this. Make it look a little nicer. Let's move the a equals negative 2 off to the side and remind ourselves that this causes our parabola to open down. Okay? All right. So, next step. Exercise 3. Now notice, all of these are going to have a very interesting outcome because they are all very basic parabolas. So let's think about the formula here. It's still y equals ax squared plus bx plus c, but in this example, b and c, where b equals 0 and c equals 0. So watch what that does to the graph. Watch what that does to this graph. It's going to make all of these parabolas, they're all going to hit the origin. Now, let's think about this first one. Okay? If a is equal to negative 2, take a guess. Will it open up or down? It's going to open down. Look at how wide it is, too. That negative 2 makes it wide. Okay? How about y equals 3x squared? Take a guess. A is equal to 3. That's a positive 3. Okay? This one's going to be less wide. hits the origin, opens up. Okay? Let's take a look at y equals 4x squared. This one's going to be even less wide, and because it's positive 4, so the 4 makes it less wide, but because it's positive, it's going to open up, and the 4 makes it even less wide, so very narrow. Okay? All right, and let's get to the summary page. Okay, pause the video, write it down, and then we got to move on. Okay, summary page. So again, thinking about y equals ax squared plus bx plus c, first of all, the first point to make is that the parabola will open upwards and look like this if a is greater than 0. Another way to say that is, or if a equals a positive value. Okay? All right. And then I wrote what he wrote in his video, but I added a little more. So this type of function, this type of quadratic function, will have a minimum y value, meaning that it has a low minimum y value right here. But it will have no maximum y value because this parabola will continue toward positive infinity, up, up, up. Okay? Now, the parabola, number 2, the parabola will open downward and look like this if a is less than 0 or a equals a negative value. Okay, and again, this type of function will have a maximum y, so I'm going to have to cut through here and point to it. A maximum y, but no minimum y, because the lower y values, the parabola doesn't have a lowest y value because the parabola opens downward and it continues downward toward negative infinity. Goes down, down, down. Okay? All right. Try and get all of this written down. Use as many pages in your notebook as you need. All right. Bye.